Alright everyone, hello. It's 8:01 now, so I'm going to start the class. So today we're going to be learning about area. What is area? Well, because we've learned so many shapes recently, there's one property that we haven't covered yet, and it's area. So area is the amount of space that a shape takes up. But how are we going to be able to find like the area of specific shapes? So the most basic way to find the area of a figure is to figure out how many unit squares lie inside it, as every unit square is one unit area. So here's a question. I'll give you guys like maybe 1 minute to do this. What would be the area of this figure, which is a rectangle that is 3 units by 2 units? Alright, it's been a minute, so now I'm going to go over the answer. So, the answer should be 6. And you can see that the area can be found by multiplying the side lengths, as the question stated that it's 3 units by 2 units. So first of all, you can just count them. And see that there's 6. But the reason why you can find the area by multiplying the side lengths is that, let's just say a rectangle has n rows and m columns. And so then each row would have m squares in it. And since there are n rows, there are going to be a total of m times n squares. And so that's going to be the area. And also, just to note that technically the units for area is unit squared if you're using the unit for side length, but I'm not really going to focus on that. All right, so next, I have another question for you guys. I'll give you guys 1 minute for it. So derive an expression for the area of a square with side length x. Alright, so now I'm going to go over the answer. So, well, we know that all squares are rectangles, so we can just use the formula for the area of a rectangle, which is the product the product of its side lengths. And since a square has all four sides equal to length x, we have that the area of a square is x times x, or x squared. Alright, so now we're going to move on to the area of triangles. So the area of a triangle is calculated as 1/2 times its base times its height. So this base could be any side of the triangle, and the height is the length of the altitude to the opposite vertex. So remember that an altitude, it's a perpendicular line through a side that passes through the opposite vertex. So in case you forgot, here's a picture of a triangle. So the bottom base, in this case, if you want to find the area of this triangle, you would multiply the length of the bottom base by the length of the altitude, which, I mean, it's clearly labeled altitude, so I hope you guys know which line that's referring to. So here's a quick question. I'll give you guys 1 minute to do it. So given that you have a triangle ABC with area 256, what's the area of triangle ADE given that D is a midsegment? Alright, so I see that some of you have gotten it, so now I'm going to go over what to do. So, here's the question again. Well, you know that the mid-segment of a triangle, it has length equal to half the base that it's parallel to. And you also know that the mid-segment divides the altitude of the triangle in half. So, okay, here's the image. So, DE is going to be half the length of BC, and also the altitude of triangle ADE is going to be half the altitude of triangle ABC. So, if you have that 1/2 base times height is 256, then 1/2 times 1/2 base times 1/2 height is going to equal 1/4 times the original triangle's area. So it's going to have area 256 divided by 4, which is 64. And if you guys learned if you guys took like similarity that we taught last class, you could also use similarity to find the area of that triangle, since there's the mid segment is going to form two similar triangles. All right, so now we're going to move on to actually proving that the area of a triangle is 1/2 base times height. So to do this, we're going to split it into 2 steps. And the first step is starting with the right triangle. So here's a right triangle, and the area of a right triangle with legs of length m and n is going to be half the area of a rectangle with side lengths of m and n. And you can see that this is because if you make a rectangle with those side lengths and you cut it in half along its diagonal, you get that right triangle, that the area that you want to find. And since two of those triangles, they have the same area and they add up to the area of the rectangle, each one is going to have half the area of the rectangle. So it's going to be 1/2 m times n, since m times n is the area of the rectangle. And also, you can notice that the legs actually form a base and altitude of the triangle. So this means that the general area of a volume formula is also going to work for right triangles, and as it should, because a right triangle is a type of triangle. So now that we've finished this first step of the proof, we're going to move on and prove it for all triangles in general. So we're going to start with a general triangle ABC. I'm gonna move on so that you can see. All right, and then you can draw the altitude from B to side AC, but like it doesn't matter which side you draw it to. So you know that the area of ABC is gonna be equal to the sum of the areas of the triangle BCE and ABE. And well, this makes sense because it's the two triangles that the altitude is splitting the triangle into. So using the area of a right triangle formula that we just derived, we can find that the area of ABC is 1/2 xh plus 1/2 yh, because, well, you're just adding the areas of the two triangles. So 1/2 xh is coming from the area of BCE, and 1/2 yh is coming from the area of ABE. And also, just to clarify, x and y are the lengths of the two segments that the altitude is splitting AC into, and h is the altitude or the height. And so you can see that if you add these two, it equals 1/2 times, in parentheses, x plus y times h. But you notice that x plus y is actually the length of the base AC, and h is the length of the altitude. So you get that for any triangle, its area is 1/2 base times height. So I'll give you guys another quick question, and I'll give you guys maybe 1 to 2 minutes to do this one. All right, so it's about time, so I'm now going to go over the answer. So, well, you just plug it into the formula for the area of a triangle. So you have that 1/2 times base times height is equal to the area. So you plug these in. You have that 1/2 times 3 times the height is 6. And so what you can do is divide by 3 and multiply by 2 on both sides to get that the height is 4. So a lot of you guys got it, and that's very good. So congratulations. All right, so I think this is going to be the final question for this area. So find the area of the 30, 60, 90 triangle if its shorter leg has a length of 2. Alright, I see that some of you have already sent me messages with the correct answer, so now I'm going to go over it for the rest of you guys. So, in a 30, 60, 90 triangle, the ratio of sides is it's 1 to root 3 to 2. And you can check this because you know that it's a right triangle, so the Pythagorean theorem is going to work. So 1 squared plus root 3 squared, which is 3, is 4, and the square root of 4 is 2. So that's indeed correct. And then, so you know that the longest side is going to be the hypotenuse. So root 3 is going to be the other leg. And since 1's smaller than root 3, so the shortest leg, if it has a length of 2, then the other leg has to have a length of 2 root 3. And so, using the formula for the area of a right triangle, you'll get that it's 1/2 times 2, and then times 2 root 3, which is going to equal 2 root 3. So that's going to be the final area of that triangle. And so, alright, now we're going to move on to some alternate methods to find the area of a triangle. So, well, sometimes trying to find the length of an altitude may be difficult because some questions may in fact just give you the 3 side lengths and ask you to find the area. So if you think about it, then how would you solve for the area then? Well, of course, you could try finding the actual altitude, but it may be cumbersome. So there's a formula that directly relates the side lengths of a triangle to its area. So this thing is called Heron's formula, or some people call it Heron's. I'm pretty sure it's Heron's. So it gives a way to calculate the area of a triangle with only its 3 side lengths. But it's quite calculation heavy, so if you have the altitude or it's easy to find, in general it's faster to do it that way. So given the side lengths A, B, and C, we can set S as half the perimeter, which is also equal, which is A plus B plus C over 2. And so the area of the triangle is going to be equal to the square root of S times S minus A times S minus B times S minus C. And so I put a note there. S is half the perimeter, so it's called the semi-perimeter. And now we're going to move on to a general tip. So in general, when you try to find the area of more complicated shapes, try to split them into triangles or rectangles or other shapes that you know how to find the area of, and add up their areas to find the final area. So I'll give you guys a few minutes for this question, and after that, I'll give you guys a break. All right, so I see that some of you have like some kind of difficulty in doing this problem, so I'm going to reveal like the solution. So you can notice that the hexagon can be split up into 6 equilateral triangles, each with side length s. And you know this because well, a full circle, a full rotation is 360 degrees, and if you split it up into 6, each one 60 degrees. So you know that the vertex of each of the triangles that meets in the center is going to be 60 degrees. And you also know that since each of these smaller triangles they're isosceles, since well the distance from the center to each vertex is the same, so you know that they're all equilateral triangles. And so now with an equilateral triangle, you can find the area of each equilateral triangle by dropping an altitude to any base. And if you do that, you get two 30, 60, 90 triangles. And well, so then the one of the legs of each of the 30, 60, 90 triangles, it's going to be 1/2 s. And so the altitude of each of the well, the other leg or the altitude of the 30, 60, 90 triangle is going to be root 3 over 2 s. So the area of each 30, 60, 90 triangle is going to be uh, it's going to be uh, root 3 over 8 s squared. And since there's 2 of them to an equilateral triangle, the area of each equilateral triangle is root 3 over 4 s squared. And then you multiply that by 6 to get the final answer, which is 3 root 3 over 2 s squared. So let me check the chat. All right. Yeah, so that was a pretty difficult question. So I'll give you guys maybe a 10-minute break, and you guys will come back and I'll continue the lesson. Alright guys, so it's been 10 minutes for a break. I hope most of you are back. I guess I'll wait like maybe one more minute and then we're gonna continue. Alright, so it's been a minute, so now I'm going to continue. So here's another question. Try to find the area of this figure. Alright, I see that most of you have gotten it, so now I'm going to go over the answer. So, well, what we can do is we can split this figure up into two right triangles and a rectangle. So, the upper right triangle, well, we see that as a base 4 and a height 2, or a base 2 and a height 4, it doesn't matter what order you put them in. So it has an area of 4. And the bottom right triangle, it also has a base of 4 and a height of 2, so it also has area of 4. And then finally, the rectangle, it has area of 9 minus 2. Notice that 9 is the distance from the left side to the to the right side. That includes the height of the triangle, so you have to subtract 2. And also, the width or the length of the rectangle, it's going to be 4 plus 4. So you have that the area is 7 times 8, which is 56. And so finally, you just add all three of these areas. So you get 56 plus 4 equals 64. So the final area is going to be 64 square units. So good job to all of you that got that one. Alright, so now I'm gonna teach you guys something called the shoelace method. So this is what you use to find the area of a polygon if you have the coordinates of its vertices. And this is helpful because sometimes, well, sometimes if the shape in the xy plane it's very irregular or complicated, it's a lot easier to just use the shoelace method. And I'll show you guys why it's called that, but you can also kind of see, you might be able to see or predict why based on the image. So here's the actual formula for the shoelace method. So if you have points A1, B1, A2, B2, and all the way to AN, BN, so it doesn't matter like how many vertices this shape has. You put them in clockwise order, and the area that they contain is, well, so this is going to be equal to what you do is you multiply along the line. So for example, A1 times B2 plus A2 times B3 plus A3 times B4, and you keep adding that until you get to AN times B1. And after that, you subtract from the, like, you subtract and then you move the line so it's the opposite direction. So instead, and then you subtract everything adding from B1 times A2 plus B2 times A3 plus B3 times A4 all the way to Bn times A1. So you can see in the bottom, and then once you subtract those two, you find half of what you find half of the value that they get. So, well, the reason why it's called the shoelace formula is if you put A1, like A1, A2 all the way to AN, then A1, and then the same thing on the right side. And if you draw the lines, it looks like a shoelace. Because I'll annotate with let's see, yeah. So for example, you can see that. Like, can you guys see what I'm drawing? Like, just put it in the chat if you can see what I'm drawing. All right. So yeah, so as you can see, if you do these on the same side, it looks like a shoelace because it forms a lot of crosses. All right, so okay. So here's an example. I want you guys to try to find the area of this triangle using the shoelace method. And as you can see, using conventional methods is going to be pretty difficult because the side lengths aren't going to be like nice numbers to work with, and trying to find the altitude might also be difficult.
You're muted.
Alright, so I see that some of you have gotten it, so now I'm going to move on to the answer. So the points are 1, comma 1, 3, comma 4, and -1, comma 8. So using the shoelace method, you write them down in clockwise, like in clockwise order. So that part's important. So well, 1, comma 1, we can start at the bottom, and then we move to 3, comma 4, and then finally -1, comma 8. And then we finish off by writing another 1, comma 1. So uh, on the right side, you multiply 1 and 4 to get 4, 3 and 8 to get 24, and -1 and 1 to get -1. You add them to get 27. And then to get the left ones, you multiply 1 and 3 to get 3, 4 and -1 to get -4, and 1 and 8 to get 8. And you add those to get 7. And then for the final area, you do 27 minus 7, which is 20, over 2, and you get 10. So the final area of this triangle is going to be 10. And so now I'm going to go over the area of a parallelogram. So like a rectangle, the area of a parallelogram is also equal to the product of its base and height. And you can see from this diagram how it's done. So what you do is you can create a perpendicular line to the base, like right as it starts to angle, and that creates a right triangle. So if you just move that right triangle to the other side, you get a rectangle. And since you already know how to find the area of a rectangle, oh, it's the same way to find the area of a parallelogram. And also now I'm going to prove the Pythagorean theorem. So of course, earlier in the course, I said that we would prove it, and since it's since it's one of the most useful theorems of all time. And now that you know the formula for area, this is how you do it. So you can create 3 right triangles that enclose a square. So each of the right triangles have legs of length A and B, and you arrange them like this. So now you're going to find the area, and the hypotenuse of each of the right triangles is going to be C. So the area of square ABCD, it's going to have to equal the area of the 4 right triangles added together plus the area of the square in the middle. So, well, from the area of a square, it's just the side line squared, so it's going to be a plus b squared. And the area of the 4 triangles, well, there's 4 of them, and each of them has area 1/2 times a times b. So the sum of the area of the 4 right triangles is 2ab. And finally, the area of the square in the middle is going to be c squared. So you set these equal to each other. You can FOIL out a plus b, the whole thing squared, to get that a squared plus 2ab plus b squared is equal to c squared plus 2ab. And then finally, you subtract 2ab from both sides to get that a squared plus b squared equals c squared. So now that we've proven the Pythagorean theorem, it's pretty nice. I hope you guys enjoyed that. And finally, now we're going to move on to the area of a circle. So do you remember the number pi? Well, it's going to be used again to find the area of a circle. So in terms of the radius r, the area of a circle is equal to pi r squared. And so using this, if the ratio of the radii of 2 circles is 1 to 4, then what is the ratio of their areas? Alright, since it's almost the end of class, and this is also the last question, I'm going to go over it. So, you can set the radius or the radii as R1 and R2, and since the ratio of the radii is 1 to 4, you can set R2 as 4 times R1. So the area of the circle with radius 1 is going to be pi times R1 squared, and then the area of the circle with radius 2 is going to be equal to pi times 4R1, the whole thing squared, and that's going to be equal to pi times 16R1 squared. So the ratio of their areas is going to be 1 to 16. So alright, thanks guys for attending this class. If you have any questions, feel free to email us. And I hope you enjoyed the class, and I'll see you guys on Saturday.